Do you have this room? Yes, for the next hour for our seminar. Okay, thanks. All right, sorry about that, folks. All right, so I'm just going to give a quick introduction and then pass it off to our speaker for today, Zane Rusk. But just to introduce myself, I am Ian Jones. I am the interim director for Center of Acoustics Research and Education, and I'm happy to present the first speaker of this year's fall seminar series, which we do every fall semester. But the theme of the seminar series this year is industry members. We haven't had a lot of industry members in the past seminar series. So I really want to fill that gap and speak with folks working in an exciting array of acoustics involved or related industries. So today it's my pleasure to introduce Zane Rusk, who is an acoustical engineer at Bose, which is a company many of you may be familiar with because they're pretty prominent in the audio world for speakers, headphones, and a lot more, as I'm sure we'll learn from Zane. And with that, I will pass it over to Zane to further introduce yourself as you like and get underway with today's presentation. So thank you, Zane, for being here today.
Awesome. Thanks, Ian. Thanks for the introduction. Hi, everybody. Like Ian said, I'm an acoustical engineer at Bose, and today I just wanted to tell you about a few things related to Bose and related to myself that I've, just wanted to share. So I'll talk a little bit about how I got to where I am in acoustics for the students that might be interested in that. And then I'll talk a little bit about Bose and some iconic innovations and products that we've had over our history. And then I want to talk a little bit about the research culture at Bose. So I'm in the research organization here. I thought that might be of interest to those that are in academic research, kind of comparing what that's like. And then lastly, I'll talk a little bit about mapping physics to perception. So jumping in here with a little bit about me. So there we go. So I kind of caught the music and audio bug early in high school. I was playing in bands. I was doing live sound at a local venue. I wanted to keep going in that direction for my career, but I was discouraged to do audio engineering, like the type of audio engineering where you work in a studio and record and mix bands. That sort of thing was kind of presented to me as, I shouldn't major in that for whatever reason. But I was very interested in science and math, so I decided to get a more traditional engineering degree and went to UT Austin for electrical engineering. And that was a good move. UT has a lot of acoustics work going on, as I'm sure many of you are familiar. It's a great place for studying acoustics in grad school, but they also have opportunities for undergrads, and I got hooked in with the Acoustical Society of America student chapter there. And, from pretty early in my academic career, was starting to get involved in acoustics. And this picture here in the middle on the right is me holding basically a broomstick with a couple of mics on it. I was helping a master's student with measurements. So I was getting experience with acoustics measurements pretty early. And also through that community was able to apply for and get a research experience for undergrads at Penn State. So I went there for a summer, and that's kind of where the rest of my academic career took shape. I got to work on psychoacoustic testing for the perception of listener envelopment in a concert hall. The idea being when you go to a performance in a concert hall, the sound, you might get the perception that sound is coming at you from all directions and enveloping you or surrounding you. And there was some psychoacoustic work going on in the lab that I joined to kind of tease apart what reflections or what incident arrival directions for reflections from the room are contributing to that perception. And so got experience with psychoacoustics, also got to go on a tour across the US measuring concert halls, which turns out is not your average grad school experience. So I might have had a little bit of a rose tinted view going into grad school on how much fun I would have. But I also went to an Acoustical Society of America conference where I was exposed to virtual acoustics or spatial audio. And this video is not really key here, but this is some work from Dr. Brian Katz, who did present at this conference. And this is essentially a walkthrough of a Notre Dame cathedral with an acoustic simulation, and it's in VR, so you can spin it around in 3D. And the idea is, actually, I haven't checked if the binaural rendering really works on YouTube nowadays, but the point being that you can do an acoustic simulation of a space. In this case, it's a space that doesn't exist in the same way anymore. And you can use what we know about auditory perception to give an illusion that someone is traveling to that space and actually hearing what they would hear during a performance in that space. And so I got really excited by that. I was doing signal processing and audio stuff in undergrad and thought this would be a great application of the skills I was building up. So I was all in on doing perceptual stuff and spatial audio. So then it came time to decide where to go to grad school, and I ended up going to Penn State because the projects I was able to pursue there had to do with auditory perception and maintained relevance to humans. So I could have gone to UT. Like I said, they also have a great acoustics program. If you're not aware, Penn State is also one of the larger schools in the US to study acoustics in graduate school. But I started off in an office noise related project studying annoyance and distraction in the presence of noise in open offices, but was able to steer into the area I wanted to go, which was headphone based spatial audio, which is actually what I do a lot of now at Penn State, at Bose. I worked on an industry sponsored project that had to do with enhancing stereophonic music with spatial room impulse responses. And I also did some perceptual studies comparing different methods for essentially over headphones presenting sound sources that appear to arrive from different locations in 3D space. So I had a lot of fun. I went to grad school during the pandemic, so that was kind of interesting. Got involved with ASA a lot. Made a lot of friends, that sort of thing. And it led me to where I am now at Bose. So kind of just to summarize for those that might be interested, how I got where I am now. Showed a lot of initiative and passion because I got interested in the sort of work I'm doing early. And so I tried to push everything in that direction as much as I could. I only got one internship, but I got a few other research experiences that I think helped a lot. Did a lot of networking and participated in professional societies, mainly the Acoustical Society of America. I owe a lot to them, I would say, but also the Audio Engineering Society. And some key skills that kind of kept my career moving are, a lot of fundamental acoustics, physical acoustics, definitely in grad school, but also acoustic measurements play a big part in what I do now and did throughout grad school, and also developed a lot of listening skills and understanding of scientific listening tests and associated statistics, which I'll touch on listening tests a little bit later in this talk. And then finally, also a lot of luck. Timing really worked out for me. it's unfortunate that a lot of things depend on timing, I would say. But when I was finishing up grad school, the position that I got at Bose was opening up. And so it was a really good fit for the experience I had in grad school. So I feel lucky for that. I meant to mention earlier, um, I've only been at Bose for about a year and 5 months. So I'm still fresh, I would say. And I got my PhD last spring. So the perspective you'll be getting on Bose for the rest of this presentation is also from someone that is uh, more fresh to Bose. And that's what I want to move into now, is kind of an introduction to some iconic products and innovations and what I find interesting in Bose history. But with that, I also want to mention there's some other Bose engineers on the line here, Harold, Joe, and Dave. And if you guys want to chime in at any point with, additional fun facts or clarifications, feel free to stop me and do so.
I'll chime in with a fun fact on your previous slide. That awesome picture with the rainbow. That was like a week or two ago, and we were looking out the window and we saw this awesome rainbow. So we decided to go outside and take a picture.
Yeah, it's brand new photography here. Bose is on a mountain, and you can get some pretty decent views up there. This was an incredible rainbow. All right, so kind of jumping in with the Bose Corporation intro here. So Bose was founded in 1964 by Dr. Amar Bose, and it was kind of based on technologies he was developing in his research at MIT. Started with power switching amplifiers for the military, but eventually, got into audio products, of course. We're headquartered in Framingham, Massachusetts. We have over 5,000 employees. And like Ian mentioned earlier, we do a lot of sound bars, home theater systems, portable Bluetooth speakers, PA systems, wearables, got headphones, earbuds, open earbuds, and we also do a lot of work in automotive. And I'll also mention some work that we do that has been done at Bose that's landed outside of audio. But first, talking a bit about some interesting products in the history. So the first consumer product was this 2201, which is a eighth of a sphere with 22 drivers on it. So if you're up on your acoustic fundamentals, you can imagine that's basically if you put that in a corner, that's going to try and replicate radiation from a point source. And it's been described as a tour de force technically, but was not a successful commercial venture. In part because a lot of people didn't have two free corners in their room to put this giant eighth of a sphere in. And this is what one of those looks like without the grill on. So you can see there's all of these 22 drivers on this eighth of a sphere. But from there, Dr. Bose did some more research, including some psychoacoustic studies, and became really passionate about this idea that a lot of the sound should be playing back into the room, not merely directing all of the sound to a listener, but also exciting the room. And that was not common at the time, but the room has a huge impact on the audio experience when you're listening to loudspeakers. And so this 901 speaker came out in 1968. It was commercially successful, got good reviews, and was run with various updates up until 2016, I believe. So it had about a 48-year run, which is pretty impressive. And we also have some cool ads that kind of demonstrate, if you imagine an image source for the 901 in a corner, you're getting all of these room reflections. So I guess I meant to mention that this unit actually has 8 drivers that point backwards, hence these kind of arrows. I'm not sure if my cursor is actually showing up, but there's 8 drivers that point backwards towards the wall, and there's a single driver pointing forward. So you're getting most of your energy reflect when at the listener position. Most of the energy is coming from you after being reflected off of the walls. And so this kind of direct reflecting technology became a hallmark of Bose's loudspeaker lines. And so we've got some other examples of that here. You can see that these speakers have drivers which aren't just pointing forwards. Some of them are pointed to the sides and other directions. This one in the middle and the center, I believe, is the 301, which was the best-selling loudspeaker for a number of years, I believe. And then on a personal note, on the bottom left, this is the 701, and I grew up with those in my house. And so as a toddler, I was, sticking my arm in the port on the front and putting all sorts of goodies in there that I would, get my hands on. I don't know if kids these days have that experience or not, but good memories. All right, so another area that Bose has been a key player in is active noise reduction. So we kind of pioneered this industry. There's a story about Dr. Bose working on this technology during a flight to Zurich, or between Zurich and Boston. So I guess at the time he was on a flight that had newer headphones. Back in the day, I guess there were stethoscope-like tubes that you would put in your ears, and that was kind of like what they had for a long time as far as audio entertainment on a plane. And this flight had something newer, but Dr. Bose was he was not pleased with it. Started drawing up plans for active noise reduction, or headphones. You can see in this picture on the left is kind of small, but these are some of his notes from that flight, I believe. That launched a research project back home when he returned. And 8 years later, Bose engineers pitched noise reduction headsets to pilots that were going to be on the Voyager flight. So the Rutan Voyager flight in 1986 was the first flight to travel around the world without stopping and refueling. And these pilots knew they were going to lose a significant amount of their hearing. And Bose engineers heard about this, and they were like, you should try out our technology. And it worked. And the Bose prototype headset went on that flight, which is kind of cool. And that leads into, the first systems that we sold were in the aviation industry, and then to the U.S. Army until 2000, when the first Quiet Comfort headphones came out as publicly available. And, of course, now active noise reduction is in a lot of earbuds and headphones by Bose and, our competitors. We kind of pioneered in this space. And then the last kind of big industry I want to mention is car audio, that we have a rich history in as well. So in 1983, the Cadillac Seville was the first car with a factory installed custom designed sound system. So Bose did have aftermarket audio system. They did a foray into that briefly, but abandoned it, and instead ended up with this partnership where we could utilize the knowledge of where the passengers are in the car and understand the cabin acoustics and where the loudspeakers are placed to kind of give the best audio experience that we can in a car. And, since then, we've worked with a very large list of auto manufacturers. So that's what I had for kind of just Bose history. Now I want to talk a little bit about the research culture at Bose as I see it. Again, mentioning that I am a relatively new employee. So I think to understand it, start by mentioning that Dr. Bose donated the majority of the stock of the company to MIT in the form of non-voting shares. And so it's essentially keeps it privately held, and that, enables us to invest in technologies with longer time horizons. And Dr. Bose was also a professor at MIT, and that's kind of a way that MIT shares in the success of Bose Corporation. So it's kind of interesting and impacts the research culture here. We don't always need to have profitability in mind when it comes to research. We don't always have to know whether something's going to work or know the end application. But I'm going to play this video for a little bit and have some Dr. Bose talk about it, or how he would talk about it. All right, so gives you a little bit of an idea historically of the kind of culture we've got. Changing gears from that, I've been talking about audio products a lot, but this sort of culture and academic connection also resulted in innovations outside of audio, which I just find fascinating. Um, there's kind of a common thread of expertise in electromagnetics that can be shared between, audio transducer design. And there's also, with active noise reduction systems, there's a lot of expertise that Bose has and had in control systems. And it turned out that those were useful in developing other technologies that were pursued in the company. So here on the left, showing a suspension system for a car, and it may be hard to tell. There's videos from CNET online if you want to check out more, but in this video, the car is, hardly the driver, from the driver's perspective, even though it's going over this very wavy section, the perspective of the passenger is that the car's not, the vibration's not being transferred very much. And that sort of problem, for a whole car suspension, it was not very commercially successful in that it was very heavy and expensive. The same sort of active vibration control was used in the Bose ride system, which went into semi trucks, and that's here in the middle. So it's a smaller scale problem that's a little more tractable, and these did go into semi trucks. And then here on the right, we've got an induction cooktop. So also using electromagnetics expertise to make a cooktop that kind of blasts a lot of energy into for efficient heating. And in this video, you can see that I think there's some other bells and whistles that maybe you don't see in your average induction cooktop today, but just some interesting things outside of audio, and some other things I didn't show here. There's Bose has kind of spun off technology in heart stent fatigue testing, which also uses high frequency motors, and there's some history of Bose engineers working on cold fusion. It's kind of some off the wall stuff, and these things in a lot of cases have resulted in intellectual property being sold, i.e. we're not developing some of these today or not selling some of these today, but that intellectual property is valuable and was sold off, or companies were spun off, that sort of thing. I think it's kind of fun. Kind of getting back to audio and what I work on, there's an aspect where demonstrations play a big role in our work. There are a lot of people around here say it's all about the demo. So this picture is in a room that has motion tracking enabled. There's these cameras near the ceiling you can see in the photo. Basically, I want to just mention that there's a big culture within research of making things that are, like we want to give an experience to a customer, and we need to convince other internal folks to advocate for our products or our projects and give us the right resources to kind of get over the wall to product development, or to continue our research and work towards better experiences. So there's a lot of, instead of just telling someone about it, you've got to show them and actually get them in the listening room and have them check it out for themselves. And there's also internal mini poster sessions or conferences and expos and that sort of thing. There's a research community at Bose. And then the last thing I wanted to mention was Bose also engages in technology licensing. So the example on the screen is this Lexi hearing aid, which is powered by Bose. So Bose had this sound control hearing aid, and it was kind of the first of what we now know as over-the-counter hearing aids, FDA cleared self-fitting hearing aids for people with mild to moderate hearing loss. And Bose doesn't make a first-party version of that anymore, but we license the technology to Lexi, and so you can still reap the benefits or hear the benefits of Bose research out in the world through that. And so I guess the point I'm trying to make there is that doing research here, it's not necessary to limit yourself to Bose's existing product line. It could, you're free to be creative and make experiences for customers that, may be outside of what we make today. Maybe your technology could be licensed to a third party partner, or, we've also historically had some off the wall examples of innovation that's unrelated to audio entirely. So I think that all kind of forms a culture at Bose that's interesting to be in. And I just thought that might be interesting to folks that are engaged in academic research, because I was a graduate student for 6 years and didn't know exactly what to expect going to industry and doing research. And I wasn't sure how that would differ. And yeah. So the last section I wanted to talk a little bit about the gap between physics and perception. And just for fun, wanted to show another video of a Dr. Bose lecture at MIT, in part as just to give the fun fact that these MIT lectures are on YouTube if you're so inclined to check out some acoustics lectures from Dr. Bose. But here at the top is the diagram that he draws on the board. And if it may be hard to read, but this orange line and label says psychophysics. So I'll let him talk a bit here. So we want to make products that differentiate in a perceptually meaningful way. And so from here, I wanted to talk a little bit about some expertise and tools to that effect, and also talk about how that manifests in the mapping of physics and perception manifests in the spatial audio area. So, yeah, talking first about critical listening and how that plays a part, there's a lot of tools that crunch numbers that help you to design things or check how well measurements match up to targets and that sort of thing. But at some point, we get critical listening into the equation here. We have people that are trained to evaluate audio systems, to compare our products to reference experiences. For example, if you're making a sound bar and you're playing Atmos music through a sound bar, there's a reference experience like this picture shown on the right, where you could have a studio that is much like the space in which the Atmos track was mixed, and you can see how closely your soundbar experience is matching that loudspeaker presentation, and you can make some argument about whether you're meeting the intention or the desired presentation of the artist that mixed that track. And you need critical listening expertise and able to do that. So Bose has, you know, lots of people that work in this space. It impacts, final products as well as the demos that I mentioned earlier. And we have a number of listening rooms that are dialed in for this purpose. Another step further, we also perform psychoacoustic testing when it's warranted. And so not every research question or not every listening test requires the same amount of rigor. It depends on what the purpose of the study is. But sometimes it's useful to quantify perception to communicate it to other people that need to advocate for resources within the company so that you can push your experiences further, like I mentioned, or get it farther down the line to product development. But sometimes we're just studying fundamental things that involve small changes in perception, and we want to know whether these changes that we're making in some algorithm or audio presentation is meaningful. And so there's a whole field of psychoacoustic evaluation. And this picture on the left is an example from one of the ITU recommendation documents for evaluating different audio systems with medium, I think it's worded as like medium differences or mid-level differences between systems. So you would switch between systems 1 through 8, compare them to a reference, and give a continuous slider rating between comparing the quality of every system to a reference. So that's the type of design of a study that might take place, carefully designed so that you can perform statistics on it and get meaningful quantitative measures out of it to say most people rated system 2 as indistinguishable from the reference or as good as the reference, where the reference might be, in my example earlier, that loudspeaker array in a mixing room, and maybe system 2 is a prototype soundbar or something. So just mentioning the kind of where scientific rigor might come in. And then lastly, wanted to talk a bit about spatial audio. So that's the area of research that I'm most involved in at Bose, and it's what I worked on in my dissertation. So first, I wanted to point out some differences between listening to music over loudspeakers versus headphones. So if you listen to music on loudspeakers and you have a nice, well-placed stereo loudspeaker setup, which if you have not heard before, you should try it out. I don't know how common it is these days, unless you're a big audio nerd or audiophile, whatever you want to call it. But if you listen to music on loudspeakers, then there's here we go. Sound waves arriving at your ears from outside of your head, right? And you'll usually perceive it that way. It'll sound externalized out in the room in front of you, and you can get a stereo image where the audio mixing engineer can kind of create this palette in front of you, or not palette, but a canvas in front of you where they can place different parts of the music or the movie or whatever it is in this space spanned by the two loudspeakers. Comparing that to traditional headphone listening, the stereo image is collapsed. It usually is not externalized. It doesn't sound like it's coming from outside of your head. And you can almost think of it as a fisheye sort of situation where this stereo image on the left would be 2D, if you will, and it's being kind of wrapped around your head in the right image. So this is, again, you can make an argument about whether this is what is intended by the folks that mixed the music, or whether this is the ideal presentation, or maybe you just like loudspeakers better. We're interested in, can we give this loudspeaker experience to someone that's listening over headphones? And so with that, we've got to evaluate, what's missing. How does sound propagate in a loudspeaker situation? So of course, if you got a physical loudspeaker system, it's going to have its own directivity pattern where it's radiating sound as a function of frequency at different amounts in different directions relative to the front angle of that loudspeaker. And so you might want to capture that variation instead of modeling it as some other radiation pattern. And then, of course, you put the loudspeaker in a room. And when you do that, there'll be reflections off of the walls. And so those reflections will arrive at your ears from different directions. And so we could consider a room model in this setup. And then lastly, there's what's called a head-related transfer function, and that's summarizing the changes that sound undergoes as it arrives at your eardrums from different incident directions. So a little bit more on that and how that gives rise to sound localization. In this picture, we've got sound coming in from a 45-degree angle. If we look at the impulse responses of the sounds as they arrive at the eardrums, the right ear is going to get a larger signal and it's going to arrive earlier in time. So this is going to give rise to an interaural time difference that is an important cue at low frequencies, as well as an interaural level difference. So here showing on the bottom head-related transfer functions. So basically the frequency domain magnitude spectra corresponding to these time domain impulse responses in the top right. So you can see that the right ear is getting a much stronger signal in the high frequencies than the left ear, as it is being shadowed by the physical presence of the head. And then to make it more complicated, the pinnae have caused complex interference and resonances of the concha and different aspects of the ear. And that gives rise to more complicated changes that your brain teases apart as it's learning your ears through your entire life to give rise to localization in the vertical direction, for example. And so we can consider all of those things when we're trying to present a virtual image over headphones that imitates a loudspeaker listening setup. And so this is my last slide, just to mention this immersive audio mode on our Ultra line of wearables is kind of doing what I'm describing, or it's the end goal is what I'm describing, where we're trying to portray a stereo loudspeaker presentation, but have it over headphones. So if I was presenting in person, I would try to give this demo to you guys. But if you happen to know someone that has, a product from this product line and you get to try it out, I would love to know what you think. And so I'm just about out of time here, but just to summarize, I talked a little bit about how I got to where I am for those that might be interested. Gave a little bit of an introduction to Bose's iconic products and innovations as I see it, and talked about the research culture here. And then gave a little teaser on how we think about mapping physics to perception in our work. So with that, I just want to say thanks for the invitation, and I'll take any questions, or if any of my colleagues want to jump in and share any more fun facts in the absence of questions, feel free to do so.
Sorry, now I'm unmuted, so you have to clap again. Thank you so much, Zane, for that awesome presentation. And yeah, it was really great to hear a bit about your background, how you came from the more academic side into industry at Bose, get a little history of that as well. It's cool to also learn about some of the history of the headphones that I use daily, and just what the day-to-day science is there. We have a little over 10 minutes or so for questions, so I'll open it up to, for folks online, feel free to either ask any questions in the chat or just unmute yourself. If there's any questions in the room, feel free to raise your hand as well.
Well, I'll go.
Go ahead, Tony.
I have at least 3 questions and a comment. But I'll space those out if other people have questions. Great talk, really interesting, I loved it. So just for your information, this is the comment. So we have quite a few here, several, who have Penn State connections. So I taught there from 2000 to 2014, 15. And we have another colleague, Tom Blanford's here. He actually was there while you were there.
Yep.
So we have a connection there. Anyway, one question is, when I was there for 14 years, I'm guessing probably at least half a dozen Penn Staters went on to Bose. You still have quite a few there?
Yeah, we do. Dave on the call here is a Penn Stater, but we have a number of Penn State folks still around, some that I know from my time there, but some that go pretty far back as well.
Yeah, old guys. Okay, I have a real question. So I know, I've been doing it in the sort of the federal funding research world forever, but I am curious about how it works in a private company that fosters research. So research takes time, and time is money, and all of you guys have good ideas. How exactly do you propose new ideas and then get those funded? Is there an internal process for vetting ideas? Do you have committees, or how does that work? If you have a good idea and you want to get some time or money to pursue that.
I'm wondering, Dave or Harold, if you would want to jump in on this. You might be able to word it more eloquently than I.
It's a great question. I'm Dave. I'm a research engineer at Bose also, and I'm from Penn State. So to answer your question on that, there's quite a few of us here from Penn State. There's time is money, and we definitely have more ideas than we have time to pursue them. So how we decide what research to do comes from a lot of different places. A lot of times the development organization or the product organization, they have a need that they want us to look into. So a lot of projects come from just what's on the product roadmap, what areas we want to get into. Some of the best ideas that happen is just kind of like someone we're at the lunch table or something, and we're just chatting about stuff. Hey, I wonder if we could do this. And the most successful approach there is to just spend a little bit of exploration time coming up with either some justification on why we might think an idea is a good idea, or coming up with a quick demo. And we have we'll come up with a project proposal and present that to the research leadership team, and then they'll decide as a committee, kind of if it's worth putting resources on. We have quarterly resourcing discussions and meetings where we'll take all of our entire research portfolio and we'll decide what the prioritization is and where resources should go.
Okay, thank you.
Anything to add there, Harold? Have something?
No, I think you summarized it really well, Dave. Hey everyone, I'm Harold. I'm also in the research group at Bose.
It's an online question. Oh, we have a question online. Thank you. Oh, it's a comment. Thank you, Jill, for coming.
I have more questions.
Go ahead, Tony.
I'm going to monopolize this guy. So what the plots you showed look like MATLAB plots. Do you have internal sort of proprietary tools, packages that you use, or do you use, MATLAB, or do you have Python? What kind of tools do you use? Yeah, those look like MATLAB plots.
So, actually, these were from my when I was at Penn State, and I just on a comedic note, I don't remember if this might be Python, and I purposely colored it like the MATLAB default colors. I kind of used both at that time, but at Bose, I would say we have a strong relationship with MathWorks, and we have a lot of MATLAB internal tools. MathWorks comes actually pretty often and gives seminars and provides support to us for MATLAB. There are some people that use Python, especially folks that interact more with machine learning than I do. I think they use Python more often.
We have a lot of internal tools that are built on top of MATLAB and Simulink that support prototyping, measurements, analysis that are all really specific to the work that we do here. And it's all infrastructure that's been built over decades. And it's to the point where when people leave Bose, it's like they're like, oh, I don't have all these tools anymore. How do I get any work done?
Yeah, I figured you would have those tool sets. If someone said, hey, I'm in a room, do you have the Ray modeling tools and the reflection tools to give me whatever? I figured you had that stuff. My last question. The three of us in this room, and a lot of us here at UNH, do underwater acoustics. So does Bose, have they played around with anything underwater?
It's a great question.
I was going to say not to my knowledge. Yeah, not to my knowledge either.
Yeah, not many consumers, I guess, underwater.
Yeah.
All right, thank you guys.
Every so often, someone's like, "Hey, how about speakers for underwater, for in a pool, stuff like that?"
Underwater headphones.
There are underwater speakers.
Yeah.
And there's really only like one company that makes them.
Bell, that's the only one I know of.
Bell.
Yeah. Maybe a couple others, but it's mainly Bell, yeah.
Quality is not part of the equation.
No, definitely is. I have one question as well, Zane. I was just curious if you could speak a little more to, what is kind of like your day-to-day work at Bose like? Are you primarily doing a lot of signal processing, like in software? Are you helping with some of like the hardware development side? Or are you helping with like some of the psychoacoustics experiments you mentioned? Or is it kind of like a mixed bag that varies by project?
Yeah, so a mixed bag of most of what you mentioned, I would say. I don't do much on the hardware development side, but a lot of signal processing. There are days when I am doing a lot of simulation work. There's days when I'm setting up a psychoacoustic experiment or listening test and running that. There's days where I'm doing a lot of measurements in rooms or in an anechoic chamber. So it kind of spans a lot of those things, and yes, a lot of signal processing.
Awesome, thanks.
There's some days where when we're putting demos together where we spend a lot of time doing listening to a lot of different types of content. So that's also pretty important.
Yeah, sometimes it's kind of I just have to stop and think of stop and appreciate we have listening rooms. If I can pull up one of the pictures. But this picture in the top left is me in one of the listening rooms that I spend a lot of time in, and sometimes I'll be in there for hours and I'm like tired, and I'm like, wait,
Can't see. You're not sharing, Zane?
I'm not sharing. Whoops.
No, I still see it.
Okay. Well, it's a picture of me on a couch in a listening room. Basically wanted to say that sometimes I just have to stop and appreciate I'm spending all day sitting on a couch listening to stuff. I guess so sometimes it's like that.
Speaking
I'll
of,
add that. Oh, I just wanted to quickly add that for those of us who do critical listening, we do spend some of our time practicing, right? Like you would work out in a gym if you wanted to stay in shape. So there's some, like hearing exercises. If you haven't heard of Sound Gym, check it out online, soundgym.co.
that's interesting. I hadn't thought of that.
Interesting, yeah.
Okay, I thought of another question, and I see time's getting short here, but, so I have two sons, and gaming is kind of their world. I'm guessing you guys are heavy into that aspect, although it wasn't really mentioned exactly, the sound part.
Yes, we had we had a gaming headset that we sold a few years ago that was it was our Quiet Comfort headphone, but had a boom mic attached to it since gamers prefer having the boom.
Yeah.
It's an interesting market. It comes up really often. For most of our products now, it's kind of like we don't have purpose gaming products, but we keep that use case in mind when we're designing our headphones and our sound bars and stuff like that.
Gotcha. Yeah.
And also, just quick, earlier you mentioned when we were talking about Penn State, I just want to mention that Tom Blanchard is how I got connected to UNH in the first place. So happy to.
Great.
Yeah.
We are happy to have him. He's good.
Yeah.
All right, well, we are just about at time, so thank you again so much, Zane, for visiting virtually and giving the excellent presentation, as well as Dave and Harold for chiming in online. And yeah, this recording will also be posted on our CARE website for anyone who couldn't make it today or wants to watch back. And yeah, thank you again, everyone who's tuned in, and hope you have a great rest of your Friday.
And feel free to visit us anytime.
Yes, absolutely. Yeah, I know. Sorry, an in-person we couldn't make an in-person visit happen this time, but we would still love to have you visit in the future if you're interested. Yes.
Yeah, that sounds great. Thank you so much for the invitation and having me.
Yeah. Okay. Thank you.
Thank you.
Thank you.
Thanks.
Stop.